Hi, algebra. You're going to be working on lesson 6 here. We're going to use algebra with the number line. This is your last section of chapter 2. So here we go. In lesson 6, we're revisiting our number line and then this rule that when you add numbers on the number line, you start to see a pattern. For example, -2 plus -2 would be -4. Go on and finish number 1. And then also on number 2, I need to add my number line first. So what number plus itself gets you 70? That's going to be 35. So go on and finish numbers 1 and 2. So we reviewed numbers 1 and 2 because now in number 3, we're going to use algebra to generalize this pattern. And that's what algebra is all about, finding a pattern and then finding a rule that helps us make that pattern work with any numbers. So we start with C, and we know that C plus C is going to equal 2C, right? Think of our buckets. Now we have the number C minus 1, so that's 1 less, and C plus 1, that's 1 more. And so if we add C minus 1 plus C plus 1, we still end up with 2C because this minus 1 and this plus 1, think of your checkers, make 0, right? And so we're left with a C here, so a total of 2C. So let's first fill in the rest of our number line. So I have C minus 2 there on the left, and now I have C plus 2 and C plus 3 over here. And so I'm going to start with my red arrows. I have C minus 2 plus C plus 2. And again, I have a minus 2 and a plus 2. We saw with our checkers that makes 0, so we still have 2C. Again, on the next line, C minus 3 plus C plus 3 equals minus 3 plus 3, they make 0, so I have 2C. So we've just generalized this pattern and why we always end up getting the same number. We get twice this number C every single time. Now this conversation down here between Michael and Jay sounds like something I might hear in class sometimes. Like Michael says, why use algebra? I'd rather just use numbers, right? We don't want the alphabet in our math. Jay says, what do you mean? Michael says, well, why did we even do problem number 3? I filled in enough of these number lines that I knew what to expect. Add the middle number to itself and you get a sum. If you add the numbers 1 more and 1 less than the middle number, you get the same sum. Jay says, you just used algebra. Michael says, no, I didn't. I was talking about the numbers and what happens with the number problems. Jay says, but that's all algebra does too. It just abbreviates everything a little more. We can use algebra to describe the same thing you described in words, and the variable shows that we can expect any number to behave the same way. Again, we're finding that pattern and we're just generalizing it to be able to use any numbers. Number 6 is a review of what we've done with the number line before. Make sure your numbers are in the correct spots here. Make sure you ask questions if you need. In number 7 now, we're going to use the number line to help us solve an equation. So if we know that a plus 3 equals 2, we're going to use the number line to solve for a. So here we are, a plus 3 equals 2, or a plus 3 is the same as 2. So I put those both on the number line. Now, I know to get to a from a plus 3, I'm just going to go back 3 spaces. And so that's at 0, and that would be at -1. So a has to be -1. Similar problem here in number 9. If a plus 3 equals 51, that means they're the same thing. They're at the same spot in the number line. And so to get to a, I just am going back 3. 1, 2, 3. And I know that that would be 50, 49, 48. So a has to equal 48. And just double check up here. 48 plus 3, yes, that equals 51. In number 10, I'm going lower 3, so -13, -14, -15. It's also good to fill in this part of your number line just to double check that yes, I am going by ones. In number 11, now we're simplifying our number line a little bit. B plus 10 equals 98. So to jump back to B, that's 10 spaces. So I would need to go down 10. So I would be at 88. And just double check, 88 plus 10 does equal 98. Number 13, now we're missing a little bit more of our number line. N minus 8 would be right there, and that's the same as -5. So see if you can figure out what n would be. Now I know that I need to go 8 units to the right. Well, from -5 to 0 is going to be 5, and so I have to go 3 more to get to n because I need to go a total of 8 units. So I'm at positive 3. And then just double check. 3 minus 8, yes, that equals negative 5. Okay, to get number 14 set up, we have m and we have m plus 6. So I'm going to set them up this way because my m plus 6 needs to be greater than m. And I know that m plus 6 equals negative 20. So those two are together. So now figure out what m would be. So to get to m, I need to go lower or become 6 less than negative 20. So I need to go 6 to the left. So I'm going to be at negative 26. Number 15, I'll get you started here. If n is negative and n plus 8 is negative, what could n possibly be? So one example would be negative 10. Because if n is negative 10, negative 10 plus 8, I would be at negative 2. So then that one is still negative, so that one works. So find some more possible values for n. Here's some examples on 15. It has to be something less than negative 8, because if n was negative 8, then n plus 8, or negative 8 plus 8, would be 0. So then it's no longer negative. Number 16 and 17 get us thinking a little bit more here. We have to decide if these are true or false. So number 16, if a is a negative number, so they drew a number line here to show that, with a being right here, a negative number, then a plus 100 is always positive. That is going to be false, and they give us a reason here. A plus 100 can be negative if a is less than negative 100. For example, if a equals negative 300, then a plus 100 would be negative 200, which is still negative. Number 17, if m is a positive number, then m minus 8 is always negative. This is also false. I drew a number line to show this. Here's 0. Here's m, a positive number. Here's showing that m minus 8 could be positive. And I gave an example. If m is greater than 8, then m minus 8 is going to be positive. For example, if m is 9, 9 minus 8 is going to be 1, a positive number. All right, algebra, you made it through chapter 2. Great work. We're making some good progress on using algebra with our number lines. So keep up the good work. Prepare for your quiz so that you do well on it, and keep on going.